In the rarefied atmosphere of hypercar engineering, the V12 engine is not merely a method of propulsion, it is a declaration of intent. For 25 years, a silent but ferocious war has raged between the historic halls of Maranello and the artistic ateliers of San Cesario sul Panaro. It is a conflict defined not by horsepower figures alone, but by a fundamental divergence in philosophy. The screaming, race-bred, naturally aspirated lineage of Ferrari versus the thunderous, forced induction torque of Pagani's bespoke AMG partnership. One seeks the absolute limit of the red line. The other seeks to relentlessly compress the horizon. Now let's open the factory blueprints and deconstruct the story of this engineering titan. When we analyze the technical architecture of a modern Ferrari V12, specifically the F140 lineage powering the 812 Superfast or the Daytona SP3, we observe a direct descendant of Formula One. Logic. The engineering priority here is the minimization of rotational inertia to achieve stratospheric RPMs. It is an exercise in atmospheric breathing, relying on complex fluid dynamics and variable intake geometry to extract peak volumetric efficiency from airspeed alone. The goal is immediacy and acoustic perfection, a mechanical soprano singing at 9,500 RPM. Conversely, the Pagani approach, utilizing the Mercedes AMG M158 and its twin-turbo successors, presents a diametrically opposite engineering solution. Here, displacement and turbocharging are utilized not merely for thermal efficiency, but for theatrical, effortless torque delivery. The engineering problem Horacio Pagani faced was distinct. How to source a power plant that offered the industrialized reliability of a German titan, yet possessed the soul of an Italian artist. While Ferrari cast their own blocks to chase lap times through high-frequency vibration, Pagani sought a partner to build a heart capable of warping physics through sheer force, without losing emotional resonance. This divergence created two distinct religions of internal combustion, setting the stage for a manufacturing showdown. To truly understand where these divergent paths separate, we must leave the theoretical domain of power curves and track the raw materials into the heat of the foundry. In Maranello, the creation of a V12 is an act of vertical integration that borders on obsession. When we observe the aluminum casting facility, we see a process steeped in Formula One methodology. Ferrari engineers utilize a specific low-pressure sand casting technique for their cylinder heads, a method chosen to allow for intricate internal geometries that maximize coolant flow around the combustion chambers. This is critical because the thermal stress at 9,500 RPM is not linear. It is exponential. The metallurgy itself is proprietary, an alloy blend refined over decades of racing data to withstand the violent kinetics of a short-stroke crank spinning at stratospheric speeds. The assembly process at Ferrari is a study in industrial precision. While human hands perform the final marriage of components, the tolerances are verified by lasers measuring in microns. The focus here is on the reduction of friction. We see evidence of this in the use of diamond-like carbon, DLC coatings, on the valve train components, a technology migrated directly from the F1 paddock. The objective of the manufacturing hunt in Maranello is consistency and repeatability at the jagged edge of physics. Every F140 engine is built to survive the punishment of the red line. Immediately, out of the crate, cross the Alps to Affalterbach, Germany, and the atmosphere. Shifts from a bustling industrial complex to a quiet, almost clinical operating theater. This is the home of AMG, where Pagani's heart is forged. The manufacturing philosophy here is defined by the one-man, one-engine doctrine. But for Pagani, the process is elevated even further. These are not standard production units pulled from a line. They are bespoke commissions. The M158 V12 and its successors were developed specifically to meet Horacio Pagani's exacting demands for elastic power. The engineering challenge for AMG was not just generating power, but packaging it. A Pagani engine bay is a tight, artistic sculpture, leaving little room for the heat rejection required by a 6.0-liter twin-turbocharged plant. Technical diagrams reveal that the AMG team had to redesign the turbocharger plumbing and the intercooler layout, specifically to fit within the Huayra's carbon-titanium subframe. Unlike Ferrari's obsession with high RPM airflow, the manufacturing hunt here focused on turbocharger geometry to eliminate the dreaded turbo lag that would destroy the analog feel Pagani craved. AMG utilized smaller, low-inertia turbines capable of spooling instantly. Furthermore, the integration of the dry sump lubrication system was a non-negotiable requirement from Maranello. This allows the heavy V12 to sit lower in the chassis, dropping the center of gravity to match the razor-sharp handling dynamics of a lighter car. While Ferrari cast their blocks to scream, AMG machines their components to endure massive torque loads, creating a sensation of endless, relentless acceleration. The contrast is stark. Ferrari builds a race engine for the road through high-volume precision, while Pagani curates a bespoke power plant through a unique cross-border collaboration, blending German industrial might with Italian design constraints. The divergent manufacturing paths resolve into two distinct data signatures on the track. When we examine the telemetry, the Ferrari V12 delivers its power linearly, a direct correlation between throttle position and rotational speed. It is a reward system built on absolute precision, requiring the driver to live in the upper echelons of the tachometer to unlock the F140's full potential. It is a frantic, glorious exercise in kinetic energy management. Conversely, the Pagani V12-AMG offers an experience of sheer hydraulic-like dominance. The torque curve is essentially flat, creating a sensation of weightlessness that defies the vehicle's mass. But beyond the performance metrics, the shared legacy of these powertrains is their defiance. In an era increasingly defined by silent electric torque and sterilized efficiency, these 12-cylinder titans represent the last bastions of mechanical complexity. They are the final proof that distinct engineering philosophy can achieve the same goal: total driver immersion, whether through the high-frequency scream of Maranello's vacuum-cast alloy or the thunderous forced induction of Affalterbach's hand assembly. Both manufacturers have successfully engineered a soul into the machine. They stand back to back, the last guard of the analog age. As we close the blueprints on this 25-year duel, the silence left behind is deafening. These machines remind us that engineering is not merely about moving from point A to point B, it is about how we feel during the journey, in the precision of their pistons and the fury of their combustion. We find the enduring heartbeat of human ingenuity.